Okay, well, it's start time. Hi, everybody. Welcome. My name is Stephanie Hagstrom, and I'm the Director of Community Outreach, Community Development for the Research Data Alliance US region. I'll be the host for today's webinar. Before we get started, I want to go over a bit of RDA, a little bit about RDA, and I'll also share some housekeeping information, and then we'll get started. Get over to my slides. So for those of you who are not familiar with RDA, the Research Data Alliance is a community of over 12,000 data experts. We just hit 12,000 last month from 145 countries around the globe who collaborate in building social and technical bridges to enable open sharing and reuse of data. Members of the RDA come together through self-formed focus working groups and exploratory interest groups to exchange knowledge and discoveries. They discuss barriers and potential solutions, and they define policies, and they also test standards. Many of the 97 active groups have produced outputs to enhance and facilitate global data sharing and reuse. The RDA also has 26 national groups that support initiatives of the members of those regions and provide a platform for those regions to interact on a global level. There are 4 regional groups of the RDA that provide resources to support and sustain the RDA global operations. The RDA US, where I work, is one of those recognized regions and is represented by over 2,500 members who help strengthen the data science infrastructure community. Today's webinar will be recorded, and I will be adding a link to the web page after this, well, probably within a day of this event. And I'll also be uploading the slides at the same location. We have allotted time at the end of the webinar for questions, and there are 3 ways for you to interact with the presenters. One is if you want to speak and ask a question, you can raise your hand in the control panel, and I'll be watching for that, and then I will unmic you so you can ask the question. Option 2 is to use the Q&A section of the webinar control panel and add your question there, and we have someone monitoring those. And the last is to put it in, our least favorite is to put it in the chat. We would prefer the Q&A because we'll have a record of it afterwards. But if you want to put one in the chat, we'll grab it and put it in the Q&A. If for some reason we run out of time for Q&A, we will collect those questions from all of you and get the answers and send them to you following the webinar. Okay. So today's, as I mentioned previously, today's webinar is hosted by the RDA US, and this is the 8th in a webinar series we're highlighting RDA outputs in 2021. This webinar is presented by the RDA FAIR for Research Software Working Group, and it's titled FAIR Principles for Research Software. I am going to now turn it over to Moran to introduce the presenters.
Thank you, Stephanie, and thanks to RDA US for hosting this 8th webinar in the webinar series highlighting RDA outputs. And hi, everyone here coming. Thank you for being here, and thank you for listening to this webinar. It is my pleasure to introduce our presenters for today's webinar, which are co-chairs of the FAIR for Research Software Working Group. Before doing so, I would like to acknowledge our working group steering committee composed of 7 co-chairs and all the active participants which have contributed to the working group in various events and consultation periods. So I will start with myself. My name is Moran Green-Peter. I am a software engineer and the metadata specialist on the Software Heritage Archive team at the INRIA Research Center located in Paris, France. I am an active member of several working groups and projects for open science and digital preservation, including the FAIR European project. Our second presenter is Carlos Martinez. Carlos is the community manager at the Netherlands eScience Center. He is located in Utrecht, the Netherlands. Then we'll go on to our third presenter, which is Neil Chu Hong. Neil is the director of the Software Sustainability Institute and a senior research fellow at the University of Edinburgh. He is located in Edinburgh, the United Kingdom. Our last presenter, but last and not least, is Daniel Katz. Dan He's Chief Scientist at NCSA and Research Associate Professor in Computer Science, Electrical and Computing Engineering in the School of Information Science at the University of Illinois at Urbana-Champaign. He co-founded the US RSE and Research Software Alliance. He's located in the United States. And so for today, we prepared a full presentation to which I'm going to share my screen now. Just a second. So it takes a second to find your screen and then the button to share the screen. Here I go. I hope you can see my screen. And we can start. So on this screen, you have more names because this is the full steering committee. We are composed of 7 co-chairs. So I'd like to thank at this moment Paolo, Michelle, Leila, Jennifer, and Fotis that can't join us in presenting our work at the FAIR4RS Software Working Group. And for today, we have a full program. I will start with an introduction to software in research, software in RDA, and the FAIR ecosystem. Then I will hand the floor to Carlos, which will present the FAIR4RS Software Working Group activities. After that, Neil will take the floor to review the FAIR principles for research software. And finally, then we'll cover the challenges and the future steps of the working group. But first, well, starting with the introduction, I want to see a little bit what about you. So we prepared a poll for you that will appear on the screen normally, if everything's okay. And to answer this question, do you deal with software in your daily work? Do you use it? Do you develop it, design it, test it, or all of the above? And I see there's a lot of all of the above, kind of a high 60%. Some only use, but some are no or not yet. That's good. That's nice to see that there's a mixed crowd here. I will continue here because we kind of ask ourselves, what is software? And I'm a software engineer, and even I have tendency to have a question, this question in mind while working. What is software? Most users look at it as a magic. So I've used this this nice infographic to show what users think. But there is the program that's behind this magic, composed from logic and data. The thing that we are not thinking of when we look at software, that is composed of digital artifacts that you can see here on the right, but it's also a concept, the software as a project, as the community around this project, and maybe even the idea of the software, the algorithm, which is not a digital artifact. So we need to take these into account. And when we look at the digital artifact, there's the source code form where the source code is human readable, and there's the binaries, the executables, and even the containers where the software is executed or can be read by a machine, but not by humans. Then we need to look on software in research, because software is used in research in the research lifecycle in a lot of occasions, and has many roles and many facets. We can look at software as a tool when you use it to produce data, to analyze data. It can also be a research outcome or result where the actual production of the research is the software itself. And it can be the object of research, where using a base of software, source code, for example, we're analyzing this base as the object of the research. And on the right, you can see that there's three important pillars that are the open access repositories where publication are kept, the open dataset repositories where data is kept, and the open source repository, which are the three open science pillars. Why are we here? There are different roles in research, and there are plurality of needs. Researchers need to archive and reference software. They need to find useful software, get credit for the software they developed, verify, reproduce, to improve results. Then you have, in a larger scale, the laboratories and teams where you want to track software contribution, produce reports, maintain web pages, and on the more organization level, to the organization wants to know which are the software assets. So here comes the second question, the second poll that we will launch for you. So your Zoom application will show you another poll where you need to answer what kind of stakeholder are you in this scholarly ecosystem. I see there's a lot of researchers and research software engineers. We have some curators and even publishers. And there's also some other role, but if you have another role, you can always share with us which role is that in the chat. It's very nice to see this, the people who are here. What do you do? How do you deal with research or software? So I'm going to continue to software in RDA. I promised to say a few words about that. There was a birth of a feather at April 2017. This was one of the first real milestones of software in RDA. This BOF was called Software Source Code Sharing, Preservation, and Reproducibility. Since then, there are established different working groups, and so we have the Software Source Code Interest Group, and then we have different working groups, the FAIR4RS software working group that we are presenting today. And we had also another software source code identification working group. In parallel, FORCE 11, for example, has also the software citation implementation working group that follow the software citation working group, producing the software citation principles. I'm not going to read to you all this chronology of sessions in RDA, but you should know that there was, from that point till today, a lot of activity around software. And this is great to see, because software is very important to research and to data. And being is as important, but different than data. We acknowledge that software is not just another type of data. And we can see that there are different recommendations from different outputs out there that software should be dealt differently than data. So here we have in the 6 recommendations for implementation of FAIR practice, we need to recognize that FAIR guidelines will require translation for other digital objects. And from the opportunity note by the French National Committee, that the specific nature of software should be recognized and not considered as just data. So this is the motivation that sent us to this adventure of creating the FAIR4RS working group. And now I will pass the floor to Carlos, who will present you the activities of the FAIR4RS working group. Thank you.
Thank you, Moran. Yeah, so just a brief introduction about the FAIR4RS software working group. So basically, this is the story of what we've done in the past few months. But I'm going to start again with a quick poll, with just a very quick question to see how many of you have heard about the FAIR4RS software working group, or even better, read the FAIR4RS software principles that we've been working on. Okay, so apparently some people have heard about it, and there's also many people who haven't heard about it, so maybe this is the first time that you're hearing about this work. So that's it's good. It's hopefully this session will be useful and will be informative for you. So as a little bit of history, the FAIR4RS software group, we were endorsed by RDA in September 2019, and we started with a plan of drafting the first FAIR principles for software and develop some implementation guidelines, and with the long-term plan of having some adoption examples. So you can join the working group, the task force, with the link below. And one thing that's important to mention is that this is a collaboration between RDA, Force 11 and Research Software Alliance. So we're like a combined task force because software is a shared interest between all of these groups. So we can go to the next slide, please. The first activity that we had as a working group was that we started with 4 subgroups, basically surveying the landscape of software and FAIR software principles and the FAIR software principles and their applicability to software. So the 4 working groups were led by Daniel Katz, Michelle Barker, Moran, and Neil. And basically the first working group was looking at FAIR principles for research software, starting from having a fresh look, so not based on any pre-existing work. The second working group was looking at FAIR in other contexts, so how they were applicable to other digital objects like workflows, notebooks, and training materials. The third working group was looking at the controversial discussion on defining what is and what isn't research software to see which parts of software should be applicable, the FAIR software should be applicable to. And the fourth working group focused on a review of research related to FAIR principles for research software, starting from the paper from Annalena Lamprecht from 2019 to our FAIR principles for research software. So that was the work from the initial 4 subgroups. If we can go to the next slide. Based on this work, we did the first round of community consultation back in February, March. And we got comments from different contributors from the community. And based on the work from the initial working groups and from the input from the community, we started working on drafting sprints. So we got together to start drafting the FAIR principles for research software. So the drafting sprints were 5 meetings that took place in April with a small task force. And basically the key challenges were finding a balance between the more general principles applicable to software and the very specific use cases that were focused on the implementation of these principles. So we wanted to stick as closely as possible to the FAIR principles for data, but also taking into account the specific needs for software and diverging wherever it was necessary. So that those were more or less the main challenges that we encountered. So we can go to the next slide. After the drafting sprints, we had like a first draft of the FAIR software principles, which we submitted for community review, and we had a full community review in June and July. So from the 11th of June to the 11th of July. We got comments again from many different stakeholders in the community, and during this period we were trying to respond to these comments and to really try to understand exactly what were the issues that were still outstanding and that were some people in the community maybe they feel we were going too far or not far enough, or that we were missing some part, and we really try to engage with all our community to get the best possible perspective. And then we had another round of, we took all this input and had another draft of round of drafting in August that led to the final output that we produced. So in total, from the start of the working group in July up until December 2021, we have participated and have planned over 60 events. These events have been really across the globe in the UK, the US, New Zealand, Canada, France and Mexico, but also in more general geographic areas like Africa and the Nordic countries. And so we've really been trying to reach, cover all the geographic locations that we have been able to reach. We engage with the community through different channels, mailing lists, webinars, Twitter, and the RDA website, of course. And we've been at many different events like the CarpentryCon, Source, IEEE, eScience collaboration workshop, and many other events. So you can see a full list of our community engagement events on our GitHub page. And now I'm going to hand over to Neil, who's going to talk about the FAIR principles themselves.
Thanks very much, Carlos. Yeah, so I'm going to be summarizing the FAIR principles for research software, giving you a little bit of context about some of the decisions that we made in bringing together all of the feedback that we got from the community reviews, and really highlighting the bits which are the same, the bits which are different, and the bits which are slightly changed with respect to the FAIR principles for research software and the original FAIR guiding principles. And then I'll kind of talk a little bit about who and what the FAIR principles should be applied to before handing over to Dan to take things forward in the last part of this presentation. So what you saw from what Carlos presented was that there was a lot of different types of input into the FAIR for research software principles. And we always intended to ensure that we were keeping the same sort of ethos and methods of the FAIR guiding principles. So we use these as a starting point. And in particular, the two things that we took from that document was the idea that the principles are there to maximize the added value gained by contemporary formal scholarly digital publishing. So we appreciate that software is as much part of the scholarly publishing ecosystem as papers and data, and to ensure that we can use different types of FAIR objects to ensure transparency, reproducibility, and reusability. And I think that reusability is really the key here for software. The other thing that we were keen to ensure that these principles enshrined was the idea that they're not something which are binary. Something is not like fair or not fair. There's this aspirational roadmap where what we're trying to do is produce a series of different principles that can allow people to make their work more fair. So we're trying to be able to show progress to increasing fairness of software. Something that's different from data is the sheer multitude of different forms. Moran gave us a little bit of a hint at all the different ways in which software can be produced and the forms that it takes. And I think one of the things that's really key to understanding FAIR for research software is that different forms may benefit different users. So a software developer might be most interested in gaining access to the source code to understand the decisions that have been made, whereas a researcher might be more interested in getting access to the executable so that they can reuse it. Having said that, we do believe that source code is often the most useful form to understand the software, and it's often the easiest form to apply the FAIR for research software principles. And then the last thing is that we recognize that there are a lot of different software engineering practices which are relevant to the FAIR for research software principles. But in many cases, they are not something that we are seeking to turn into a principle itself. They're things that help us to implement and to adopt the principles that we're setting out here. So there are different things that might improve findability, accessibility, interoperability, and reusability, but we're not choosing to take the software principle and put it in as a FAIR principle directly. And some of that will come out as I review the different principles. Next slide, Moran. So these are the FAIR principles for research software. I'm not going to expect you to be able to kind of look through and read this all at once. What I'll do is over the next few slides, go over each of the different foundational principles and talk a little bit about what is the same as with the data principles, what is slightly changed and what is new. These principles are an evolution of the form that we had them in the community review, and they represent the kind of current draft of the final version of the principles. So what are the things that have changed? So let's start with Findable. So with Findable, the main difference here, because most of it is very similar, is that we've chosen to extend the F1 principle, which is about assigning objects globally unique and persistent identifiers, to take into account the slight differences with software and the complexity that we see in the software ecosystem. So here, the big additions to the Findable principle are that we've added F1.1, which is about giving distinct identifiers at different levels of granularity. And so what we mean here is that we recognize that software has dependencies and software has different levels of granularity, and that you may need to identify these differently. And also to give identifiers to different versions of the same software, because software evolves and each version needs to be identified separately. All of the other kinds of principles more or less take the same forms as we have for the FAIR guiding principles around ensuring that there is sufficient rich metadata, ensuring that the identifier for the metadata is clearly described, and ensuring that metadata themselves are fair and searchable and indexable. So let's move on now to accessible. So with accessible, we have to recognize that the term accessible has a very different meaning in the software engineering world. So often for software engineering, accessibility is around ensuring that there are no barriers to the use of the software. For instance, if people are using a different, have a different native language or have a disability that makes it harder to use certain interfaces. With accessible here for the FAIR principles for research software, we've chosen to use the definition of the term that comes from the data and the original guiding principles. But we're not ignoring accessibility in the software engineering sense. We'll come back to that when we talk about the reusability and how that's described for the FAIR principles for research software. So here what we have is very similar to the FAIR guiding principles for research data, where what we're looking at is making sure that software is retrievable via standardized protocols. So those protocols are open and free and universally implementable. So in the case of software, for instance, a lot of people will use protocols such as HTTPS or perhaps FTP or SFTP. That the protocol allows for authentication and authorization where necessary. And importantly, I think for software as well as for other things, that the metadata are accessible so that you can find out about software even when it's not available. Okay, so let's go on to interoperable. Interoperable is the one that probably is most different from the data principles. Interoperability for data is mostly about the understanding of formats and standards and the way that the data is described. For software, it is about data formats, but it's also about the way that information is exchanged. So here we're talking about things like application programming interfaces. And so what we have is one principle which has changed. So it's written more in the software context about software reading, writing, exchanging data in a way that meets domain relevant community standards. And here we recognize that different domains have different ways of exchanging data, of creating APIs which are useful, and the level of documentation that is required. But also that software includes qualified references to other objects. So we still need to know about the other research objects, research data, parameter files, and so on, that will be required to be understood in the same context as the software that's being identified. So finally, let's move on to reusable. So for reusability, the way that we look at software is thinking about making software both usable, so can you execute it, and also reusable, so can you understand it, modify it, and build on it. And in many cases, a lot of this is similar to the FAIR guiding principles for data. Does it have a license? Does it have detailed provenance? And does it meet the relevant community standards? The one thing that we've added to the principles which is specific to software here, is the idea that software should include qualified references to other software. Software is rarely existing in its own independent state. It will have dependencies, it will have requirements on other pieces of software. And so we think it's important, if software is to be fair, that it includes those references as well. Okay, so that's a very quick overview of the FAIR principles, and we're happy to take questions later on about any of the specific details of these principles. But just to kind of finish off before I hand over to Dan, I wanted to kind of touch on now the question of who's responsible for FAIR software, because software is different from data, principally because so much software is effectively self-published. It is made available by the authors through web pages or through code repositories. Currently, only a fraction of software is being published through different types of repositories such as Zenodo. So then who's expected to apply FAIR and why should they do this? So I think the principal thing is that the application of these principles is the responsibility of the owners of the software. It's not the responsibility of the users of the software. And so we've got to make this process, basically, we've got to make sure the adoption of the principles hits the owners of software and the people who are developing software. And I've got a diagram here on the adoption cycle, which we'll hear a little bit more about, which is really about understanding all of the different stages it takes and the fact that all of these are interrelated and feed into each other to ensure that we give the incentives, the policies, the infrastructure, the training and tools, and the community uptake to ensure that owners of software look to apply these FAIR principles. But the last bit there is also about ensuring that we understand that the FAIR for research software principles are relevant to a much larger ecosystem, and there are many other stakeholders, as evidenced by the question that we asked at the start of this presentation, that will need to help support research software and also help support the adoption and implementation of the FAIR for research principles. So before I hand over, there's just one question I'd like to ask everyone, which is, having seen all of this, do you actually think research software should be fair? And in particular, what sorts of software should be fair? So is it all software that should be fair? Is it just software that's created during the research process? Is it more nuanced than that? Is there something about the context? Or actually, do you think that it's not appropriate for software at all? So looking at the results here, I can kind of see that there certainly isn't anyone who says so far that software shouldn't be, you shouldn't apply the FAIR principles to software, but also that all software possibly shouldn't be fair. So there's a few people now that are doing this. So I think a lot of people are basically saying that it depends on the context, that there's certainly software that should be made fair, but perhaps there's some software that doesn't need to be fair as well. Okay, thank you very much for that. So I'm now going to hand over to them.
Right, thank you. And so I'm going to start off by talking about some of the challenges that come up, particularly in the context of, as Neil said, that FAIR is really aspirational. And so if we wanted to make FAIR easy and happen all the time, what would we need to do in order to do that? So go on, Moran. So the first challenge is really related to metadata and identifier authority. And specifically, the problem is that research software to become FAIR needs to have unique identifiers and associated metadata. But it isn't really clear how those identifiers are created and maybe even where they're stored. And for the metadata, where is it created and stored and maintained? And so with metadata specifically, there's kind of two options that we are thinking about. One is that the metadata is intrinsic and to the software. For example, it's stored in a JSON file in the source code repository. And that means then that it would be guaranteed to be controlled by the authors, but it would have to be exposed by some way to make the software findable. The other is, if you think of the the case of software that's deposited in a repository and has metadata associated with the DOI, for example, is extrinsic to the code. And this makes the software more easily findable, but then that metadata is controlled by an external authority and it can't be changed by the authors as easily. So that's the first challenge. The next one is regarding the metadata vocabularies and properties themselves. There's really no community agreement on what vocabulary should be used today. The vocabularies that are used by package managers to describe software don't capture some of the metadata that's needed about research. And there are relatively few discipline-specific vocabularies that do capture metadata about software development and usage. So this process of how metadata vocabularies and standards are established is an intensive one for which resources are limited and which really has to be done in a community by community basis. So again, second challenge. Third, back on identifiers, is that there's not even agreement on what identifiers we should be using for software, even for the specific case of giving software authors credit. There's a bunch of different classes of identifiers. Sometimes we think of this as an identifier zoo. And these identifiers are independent and not clearly interoperable. So I guess if we take the zoo metaphor a little farther, all the identifiers are in their own cages and they don't necessarily get along well. And so we could think about different ways of addressing this, maybe through a community endorsement process. But if so, we'd have to do this in multiple communities again. And so this is, again, a challenge. Next, we have, what does the identifier actually point to or refer to? What's the target of the identifier? If we think about open source software, maybe this is the repository in the open source system or in a repository. For commercial software, it's not really clear. For a container, we don't know. For a service, we don't necessarily know. Maybe for a service, it's a URL or something like that. So this is discussed in the principles document when we talk about granularity and versions, and it's also related to the idea of a software concept, which is the set of all specific versions of that software. This shows up particularly in citation, where you might want to cite a specific version of software, but you also might want to cite just the concept of the software, and you're not really talking about a specific version. So we need identifiers for both. There's other work that's also highlighted challenges related to the linkage of scientific knowledge and software artifacts. Next. One of the other challenges is that software is often very complex. If you think about open source software in a repository, it contains other software, it contains documentation, it can contain data and metadata. And all of these can have versions, and all of those versions can change at different rates. And so how do we actually deal with this? Where should we apply the FAIR for research software principles? And where should other parts of the FAIR guiding principles be applied, particularly if we're thinking about the data that's in the software repository or the documentation? Which of these things should have their own identifiers? And how should relationships between them be described in order to be fair? And it seems that experience from applying the FAIR guiding principles to complex data collections may provide solutions, but that's something that is not, I would say, completely well understood yet, even for data. Next. There's also some questions that came up in the community review about whether FAIR should be recursive. And the idea here, if you're thinking about software, is that the software is only fair if its dependencies are also fair. But even if we just thought about this simply with data dependencies, or really any dependencies, this would mean that it would be very hard to implement the FAIR principles in most practical cases, because it would require that you'd have to have measurable, actionable guiding principles that are applied down the entire dependency stack. And this would mean that you actually couldn't make any software fair because the authors of the software wouldn't have the responsibility or even the ability to make the dependencies fair, since that's coming from other authors. So I think the answer to this probably is that it's not required, but it comes up a lot in discussion. So it's probably something where more discussion is needed to make this more clear. Neil talked about the accessibility definition before, so I'm not really going to say that, other than, as Neil said, there are these two different definitions of accessibility that we need to worry about, which we mean in which context. Reusability, we have the issue that for software to be reusable, And it has to really be maintainable and dependable so that you can use it for different purposes. And this is maybe captured in principle R3 and reusability, but it might require additional clarification. Again, as Neil was saying a bit, to think about how is FAIR related to some of these other things. Let me just leave it at that. That FAIR is not the end goal, and there are a number of other things that are also desirable, but we can't do everything at once. So, right, so as I was saying, FAIR is not the end goal. This is kind of more my opinion than it is in the document, but I think this is generally things that most people would agree with that were involved in writing this. We have a set of goals for research software and the research that it relies on. That in general are that research software is open, although maybe not in all cases, but it's a general goal. That research software is high quality and robust. But again, that's different than FAIR, and that's not required for FAIR. That all research software is findable, accessible, usable, and used by others, or reusable, and it's cited when used. And again, only the bold part of that is FAIR, the citation is not. That contributors to research software are recognized for their work and they have good careers. That research software is sustained as long as it's useful, and that all research is reproducible. And so if we're trying to do all of these things, we just have to recognize that we can't do them all through one set of principles. The FAIR principles are doing part of this, but we have to overlap and interoperate with a number of other communities that are trying to address some of these other pieces as well, and really work together with that. Next. Okay, so another poll question. So having talked about this then, what aspects of making research fair do you think would be the most challenging? And we have options of metadata, identifiers, structure, fairness of related objects, definition of accessibility, definition of reusability, at least 3 of these or all of them. And I see some answers coming in, which is great. Looks like structure is a popular one. I guess I'm reasonably happy nobody's talking about the fairness of related objects. Maybe I was convincing with that. But there's actually quite a lot of people that are also saying at least 3 or all. Okay, so let's go on then. So thank you. All right. So having said where we are, that we've developed these principles, we've talked about them, we've done some community feedback. We're just in the process of creating the final published version. And we know we have all these different challenges for FAIR, as well as all these challenges that are outside FAIR. Where do we go from here? So we're starting 3 new subgroups to do 3 things that we think we can focus on. And these are numbered 5 through 7 because, as Carlos showed, we had subgroups 1 through 4 before, and so we don't want to get confused with numbers. Subgroup 5 is going to be looking at adoption guidelines. So how do we identify and create and review existing resources that can facilitate the adoption of the FAIR for research software principles? Number 6, subgroup 6 is going to be adoption support, where we want to identify and start working with organizations that are either following the principles or are interested in doing that, to stimulate the adoption of the FAIR principles through those groups, and then to document and share the examples of those groups that they have so that other groups can learn and have an easier time. And then subgroup 7 is going to be governance, to create a communications plan and content that clarifies the post-release governance structure of the principles. We had a workshop on Monday where we were talking about FAIR in general, and one of the lessons that came out of that is that the FAIR data principles didn't talk about governance, and they didn't talk about how they could be changed as part of those principles, and that's clearly a gap that we want to address here for these principles. Maybe somebody could put the link to the forum into the chat if anybody wants to join one of these subgroups. And we'll go on to the next slide. So then the next steps back one, please. The next steps that we're going to then go through are publicizing the principles through the new subgroups in part, developing curriculum and training, developing and encouraging tooling, encouraging adoption, considering future governance, but then also trying to do some community work around these gaps and these challenges that I talked about before. And then another piece that's an interesting question is, can we define metrics to measure adoption? And this could either be adoption of specific software, so how fair is specific software, or it could be how are the principles as a whole being adopted by the scholarly community. Next. So if you're interested in getting involved, you can join the RDA group. You can join one or more of these new subgroups that are really just starting out. You can come to our events. We have monthly steering committee meetings, and those are public, and you can follow the minutes or come to a meeting. You can say hi on our Twitter channel. You can read some publications that we've written on Zoto, and we've also collected some bibliography of what we've done, as well as what other people have done that we think is important in Zotero. And all of this is detailed on the community engagement channel, and maybe somebody can post the link to that one as well in chat. And next. All right, so just to acknowledge a few people before we go into questions, there's 4 of us out of the 9 working group co-chairs that are here. There are 5 others that are listed there. We've had 228 members and contributors to the working group at this point, which I think is great. I was really excited we've gotten that many. We've had some past steering committee members as well who have helped with a range of activities. And the Alfred P. Sloan Foundation and the Wellcome Trust have provided some funding to help us with some of these activities. So I think that's the end, and we go to questions now. Is that right? Oh, no, sorry, we have one more poll question, which is an open question.
Well, it's actually not a poll question because we can do open poll, but sorry, I will come online. And yeah, we want your opinion in the chat about this final question about what is the most important item we can provide to push forward FAIR for research in your institutions.
So yeah, so if anybody wants to put any answers in the chat, that would be great. And I think with that, we will thank people for joining and go to questions. Sorry, or do we? Yes, we go to questions. So I'll just comment, since I'm speaking, that there's the question from Vinod about how about collaborating with CHAOSS on developing the metrics for FAIR principles, and we are doing that. So the CHAOSS folks have been involved in the discussions that we've been having, and that is one of the means that we have to go forward. So thank you for that question.
Moran, would you like to repeat that question, that the poll question you had at the end, to see if anybody might want to get some feedback on that?
I'm trying to get back to the slide. Yes, sure. So the final question was, what is the most important item we can provide as the FAIR for Research Software Working Group that can push forward the principles in your institution so that we'll have fair research software outputs?
And I see we have one more question from Anna that maybe maybe Neil would be the right person to answer, but
Carlos said he would answer this question.
Okay, Carlos is going to answer. Yes.
Oh, I think Neil can probably answer these as well. I just clicked on the button without knowing what it did.
Oh.
So I'm just reading through the question here. So there are communities that have explored FAIR data guidelines or FAIR research guidelines. Wouldn't it be helpful to have several examples of combinations of research data software being made FAIR? Yes, so certainly I think it's important to not see FAIR software as somehow being separate from the others and providing different guidance. And that's one of the things that we're looking to do to help, as Dan mentioned, support the adoption of the principles by working with different communities. So I think there are some examples that are starting to come about from different communities, particularly in terms of understanding data and software. I think there's another thing there that's coming up, and Dan may be better placed to talk about this, around FAIR for things which combine all of these. So FAIR for machine learning, FAIR for notebooks, and FAIR for workflows. But there's also the thing that you mentioned, Anna, about could you comment on the applicability of research object crate and making research data and software adhere to FAIR principles? I think that's a really good question. I think one of the things that these sorts of things where you're trying to effectively, I guess, package different discrete research objects together is that it will make it easier to handle metadata and to improve the findability and accessibility of research data and research software and other things combined. And so I think the question will be, how do we ensure that we produce, or we help the communities that are involved with Research Object Crate to produce guidance that helps researchers implement the FAIR principles? So a good question there.
Yeah.
I don't know, Dan, do you want to say anything on kind of like mixed things for machine learning or workflows?
Yeah, I mean, I actually, I think that this question is great because it actually gives me a chance to stand on this little soapbox that I have and comments that I think that the original FAIR principles did a very nice job at that time, but made a bunch of assumptions that I'm not sure that people realized they were making. And it's when we start to actually do this application of FAIR to these other kinds of things, research software in our case, some machine learning model work that I'm starting with FOTUS, workflows that Carol Goebel has been doing a lot of work in, notebooks that Hugh Shanahan has been working on for a couple of years. We realized that the original FAIR principles did have these assumptions and that they really limit how we can use them for these other objects. And so we kind of get to these two different challenges, two different possibilities of having completely different FAIR principles for different kinds of objects, or having a very general set of FAIR principles that can be customized in some way for different kinds of objects, or maybe even a FAIR framework under which we could have different FAIR principles as instantiations. And I don't think we really have any idea yet what the right answer is, other than that having one set of FAIR principles that was created for one kind of object is not the answer that's going to work for other kinds of objects.
Dan, there is some thing from David in the chat that you might want to look at and have a little comment. He's got two questions. One, I would argue that for software to be reusable doesn't only require to be maintainable, but to be actively maintained, at least for languages evolving rapidly. Old Fortran code might still be FAIR today, but old Python code certainly not. And then he commented, again, I feel there should be a distinction between the FAIR principles for RS itself and for services, e.g. API, running the software on remote servers, for example.
Right. So I guess I kind of just want to jump in with one thing, and then Carlos had a comment, so I should let him also talk. But just really quickly, I think when we say reuse, I don't think we completely know what reuse means for software. And I don't know that we can say that reuse always means re-execution, right? Sometimes reuse might just mean rereading. So old Python code that's not runnable still has value, and it still can be used by reading it. So this is one of the complexities of software versus data, is that there are these different kinds of use that we can consider. Carlos, you want to comment on what you were saying as well?
No, I just yes, you're right. I think that's one of the complexities. I think if we think about rerunning old Fortran code, that's still runnable for the most part. And old Python code, yes, you might need to migrate that if you want to continue running it. So if a piece of Python code still is useful, it should be maintained if you want to still run it. Python 2 code that you used 10 years ago that you want to use today to reproduce some results needs to be maintained before you can run it. So yeah, just that.
I want to jump in just for the second comment about the separating software and services. And we have a debate on that at the last plenary. And I think that we don't agree, well, as chairs, but also as a working, we do not agree on this. But I personally think that it should be separated, and services should be regarded separately than software outputs like artifacts, source code, and executables. The services that are online and need to be maintained, to be used, and are also sometimes not free to use or to read behind that.
And if I may just kind of add one more thing to that. Yes, I think this is something that will need to be explored in the work that's being done on FAIR for workflows, because I think there's an interesting difference between the service that is operational and the service as the piece of software that is the concept of that service and the implementation of it. So as Moran says, this is still something which is very much up for debate, and I know that even the four of us do not agree on that.
Right. Also, just going back to the RO crate idea, I think that I was just thinking again of machine learning models where a trained model may want to be kept and put together along with the data that was used for the training. In which case, you could think of the data being subject to the FAIR data principles, and the machine learning model itself maybe being subject to software principles or maybe data principles, and we don't know yet. And how we put those together, I think, is a challenge. I mean, putting them together in an RO crate is fine, but then what FAIR principles do we use and what metadata do we use are still really open questions.
I think that we should hand back the floor to Stephanie, because we are 4 minutes to the hour. Thank you very much for having us here. And
thank you so much, Moran, for all of your help. I want to thank the speakers for your presentation today. And Moran, thank you so much for all the coordination, and Megan for your behind the scenes technical help, and to the audience for attending and for all the great questions and contributions. As mentioned earlier, this webinar and its slide deck will be available on the RDA website. Probably I'll upload the slides today, and the recording will be up in a day or two. I wanted to bring to your attention a few things, upcoming events. First of all, if you go to the RDA website, there is a menu item called plenaries and events, and you can see all the events, but we do have some RDA US hosted events coming up. In October, we have a joint RDA ESIP physical samples webinar, and it's supporting interdisciplinary sample data discovery, integration, and reuse. And then on the 21st, we have, as part of our Highlighting RDA Output webinar, we are featuring a How to Get Attention for Research Project Outputs on the 21st of October. And that one is presented by Jennifer Gibson, who is going to be the Executive Director of Dryad and was formerly the Communications Director for eLife. So that one might be interesting to anyone that's putting on projects. And I'm sure we could learn a few things from this group, for sure. Also wanted to let you know that our plenary 18 will be convened online November 3rd through the 11th. And there are some preliminary webinars to help navigate for those of you who are not familiar with the plenary, or these are even good for people who've been there before. But on September 28th, there will be one. Our first one is what to expect when attending an RDA plenary. And then the second one and last one will be October 26th. This one's about navigating all things RDA, including the plenaries. So if you're not already a member of the RDA, we would encourage you to join. I've put some URLs up on the screen and a few links that might help you navigate around our website. We encourage you to become a part of this community. And there is also a newcomers page, which is helpful for those who are not familiar with RDA. And I want to say, on behalf of the RDA and the RDA US, thank you all for joining us today, and we hope to see you again soon. Bye-bye.